In this lesson, we'll try to understand what is a perfect differential. If we have to differentiate d of say x cube y, this is a product of two functions. So we keep one constant, differentiate the other. So we get x cube, and if we differentiate y, we get dy. Then we keep the other one constant and differentiate the first function. X cube, if we differentiate with respect to x, we get 3x squared. And when we differentiate x, we get dx. So this is the differential of this. And this quantity is called a perfect differential. This is equal to d of x cube y. So d of x cube y is x cube dy plus y into 3x squared dx. And therefore x cube dy plus 3x square y dx is nothing but d of x cube y. Same way, suppose we have to find d of 2y to the power 4 x squared. 2 is a constant, so we can just keep it out. This is a product of two functions. We keep this constant first, y to the power 4. Differentiate x squared, we get 2x dx. Then we keep x square constant and differentiate y to the power 4, we get 4y cube dy. So this is what is the meaning of d of 2y to the power 4x square. It is same as 2 whole into y to the power 4 2x dx plus x square 4y cube dy. So this is equal to this, and therefore this is equal to this. Now suppose we have to integrate x cube dy plus 3x square y dx. Now how to integrate this? Now if this is a perfect differential, then you can integrate it directly. Now to check whether it is a perfect differential, integrate this term with respect to y, keeping x constant. So integrate, because y is there, dy we integrate with respect to whatever it is, dy or dx. Here integrate with respect to y, keeping x constant. So now we'll keep x constant and integrate this function with respect to y. So x cube comes out, we get integration of dy, which is x cube y. And now this term where dx is there, we'll integrate with respect to x, keeping y constant. So now we'll treat y as a constant. Then we get 3y outside, we have to integrate x squared dx. And we get 3y x cubed by 3. This 3 cancels out. So we get x cubed y. And if these two are same, now they are same here. This is a perfect differential. And this is equal to d of x cubed y. So integration of d of x cubed y. Integration is opposite of differentiation. So integration of d of x cubed y will be x cubed y. Integration of dx is x. Integration of dy is y. Integration of dz is z. So that is very simple. So integration of d of x cubed y will be x cubed y. So if it is a perfect differential, the integration can be done without knowing the relationship between y and x. Now we can have a question to check whether the given function is a perfect differential or not. For example, suppose we are given 4 xy squared dx plus 2x squared y dy. Now we have to check whether this is a perfect differential or not. So here dx is there. So we'll integrate with respect to x, keeping y constant. So y is now constant, 4 is a constant anyway, so we get 4y square. Integration of x dx. So 4y square. X square by 2. So we get this as 2x square y square. Okay, here y is constant, so y square comes out, 4y square comes out. In fact, integration of x square, x dx is x square by 2. So we get 2x square y square. Now if we integrate this with respect to y, keeping x constant. So now x is constant, y is the variable, 2x square, integration of y dy. So we get 2x square, y square by 2, x square y square. Now these two are not same, they have to be exactly same. They are not same. Therefore, this is not a perfect differential. So this function we cannot integrate without knowing the relationship between y and x, or x and y. Now, let's have a look at another question. In this question, again, you have to check whether the function is a differential or not, perfect differential or not. We have got 4xy dx plus 2x square x square dy. So this is the function given to us now. Now we'll integrate this with respect to x, keeping y constant. So therefore 4y is outside, integration of x dx. So this will give us 4y x square by 2. So we get 2x square y. Now here we integrate this, keeping y constant, x constant. So 2x square is a constant. Integrate dy. So again we get 2x square y. This and this are same. Therefore, this is a perfect differential. And this is nothing but d of 2x square y. And if you have to integrate this, the integration will be 2x square y.